Hey guys, and this is the longer version of the tutorial, and we're going to be making this step by step, and hopefully it will be enough information to get even someone who is not familiar with geometry nodes a good start with geometry nodes. So yeah, let's first look at the project. You should be able to download the project files. Let's first go through all the nodes, and then we can recreate the project from scratch. But after we have gone through the different things that we are doing, and then you will know why we're doing it. So the first thing I did when I started the project was I created this curve here that I used to control the tornado. So you can see I can change the direction of the tornado just like that. I import it into geometry nodes here as a curve like that, and resample it to add more vertices. I set the radius, set the tilt, that is just the twisting, but you don't see it until I turn this into a mesh. So after that, I store some of the data because we are converting a curve to a mesh. When you do that, that data gets lost or gets destroyed. So we're just storing it in a variable here, so that it transfers over to when we convert this to a mesh. And here we convert this to a mesh. And all the stuff we added before, like resampling, curve radius, set curve, tilt, all of that now can be previewed here after we turn this into a mesh. And I'll give it even a curve profile. I'll add a subdivision surface to make it smoother and also get more subdivisions. And I did some UV unwrapping here, but the final thing, I really didn't use it because I ended up using a volume, and that doesn't really need any UV maps. I added some noise and then subdivided this further. That gave it even more smoother wrinkles. I'll call them wrinkles. And then it was too smooth, so I added an extra layer of noise to make this look even more turbulent. It's also at this stage that I rotate the object. Yeah, if you're rendering this as a volume, having it open like this creates some issues. So I had to close it at both ends, at the bottom and the top, so that it's an enclosed volume. That way it can render correctly. So you can see here I separated the boundaries, basically this edge and this edge. I separated those edges. You just have to select edges that have one face, For example, this edge has only one face here, and this one also has one face. But if you look at this edge here, it has this face. It's connected to this face and this face. The bottom is also open, so these edges are also connected to only one single face. That allows us to create this selection using edge neighbors. So delete any edges that have a face count greater than 1. So anything that is not these boundary edges are going to be selected, and we delete them here. Extrude these edges just like that. Scale them up, extrude them again, and scale them in. Join these together. Now we have an enclosed volume. To really enclose it, you need to merge by distance, because before these are 3 different elements. So you have this, and then the middle part, but they are not connected. So you merge them together, and so that their vertices are connected to make it an enclosed volume. And then we turn this to a volume. Then you work on the materials, you work on the shaders, and you get exactly what you want. So let's do this step by step. I'm just going to open up a new blend file here. Go to geometry nodes, Shift A to add a curve. You can tab into edit mode, hit V, turn this to automatic so that these points are easy to move around. So I'm just going to rotate this on the X to 90 degrees so that this is tall. This is going to be the structure of our tornado, and when you edit this curve, the tornado will be edited as well. So let's add a plane, and let me add a new geometry node setup. So the first thing I want to do is importing this curve, and the way you do it, you just find the curve, drag it into your view, and if you have the node wrangler add-on, you need to go to under edit, preferences, add-ons, and type in node wrangler. It's a very useful add-on, so make sure you always have it so that you can use some of the shortcuts you're going to be using here. So if you use Ctrl Shift and click on any of these outputs, you can preview them quite easily. So you can see if I want to preview the geometry here, I can just Ctrl click on that, and I should be able to preview this. And let me disconnect this for a second. So this is what we have. We're previewing the curve itself. You can turn on relative so that whenever you move the original curve, the geometry also moves as well. So let's turn this into a tornado. So the first thing we want to do is give this some profile and make it round like a cylinder. So I'm going to search for a curve to mesh. This allows you to plug in a profile for our curve. I will want to just use a circle, curve circle, and make sure you enable the preview so that you can see the results. We want our tornado to have a taper effect like that. That's very easy. All curve objects come with a curve radius that you can adjust to change the thickness of the curve. And this is easy to demonstrate if we add a curve object here. Take this, and actually I should show you what we're doing here before we even use geometry node. So we have a curve, we want to give it a thickness, and in the normal way of doing it in Blender, you just go to the curve properties or curve data. Under geometry, you can give it a depth, the thickness you want. You can even add resolution, but you can also control this depth per curve point. So if you select any point on the curve, you can use Alt S and change the curve radius at that point. That's basically what we're using. We are setting the curve radius of these points using geometry nodes. Then later we will displace this geometry, and there's also a curve tilt where you can change. Actually, the curve radius is also a tool here that you can select here and change the curve radius directly there. I also wanted to show you this curve tilt, which just changes the rotation of the curve. So basically this is what we want to do inside geometry nodes. So let's go back to that and take a look at our geometry nodes. Just have to go back to the plane and take a look at this. So let's create this using the set curve radius. Set curve radius. Basically doing this here is equivalent to just using Alt S or just selecting the two different points and changing the radius like this. But we want to change it for individual points here. And to access that, we can use the spline parameter. So if you search for spline parameter, it gives you this factor. And if we just preview that on the curve, I'm just selecting this curve and previewing that, you can see we have a gradient that goes from top to bottom. This gives you the factor which starts at the first point on the curve and then as 0 and then the last point as 1. So and then here we have something like 0.9, 0.8, 0.7 and until we go to 0. So we can use that to set the curve radius at each of these points. So I can just come in here and use that here. Now if we preview this, you can see at this point, the point at this point has been given a curve radius of 0, and then at the bottom here a curve radius of 1. But we want to have multiple points, so I can use a resample curve and add as many points as I want. That will also help with the resolution. Now we want the inverse of what we have here. So we want this cone to flip over so that the smaller part is at the bottom, because that's how tornadoes are. So I'll just use a float curve, which just maps the values from 0 to 1 onto a curve like this. So when I change anything like that, I can basically get the same profile that I have here. But we want the opposite of this, so I'm just going to change this to something like this. We don't want it to be too small at the end there, so I'm just going to open it up a bit, just like that. The only thing that is left is to twist this around, and again, in the ordinary way of doing it, you can use tools like the tilt curve to just change the tilt of any point you have, just like that. So in geometry nodes, we can access the same thing using the tilt, the curve tilt. Use the set curve tilt, just like that. And again, we can rotate this, but like we did before, we want to use the factor for that. So I can just connect this directly like that and use a math node to multiply, to increase that tilt if I want. So multiply this at the tilt I want. So that's where we are. Let's add some noise displacement into this. I'll come here and add a set position. This will allow me to change the position of each vertex here, and I can use a noise texture. If I plug this directly into the offset, for some reason this whole thing has been shifted a bit to the left from its center, and the reason for that is that it seems that the noise texture has an offset that you have to subtract if you want to keep things in the center. So I'm just going to use a vector math and subtract a value of 0.5 on each axis, and you see that everything centers back. So if you're having the same issue, just do that and you see that things are centered back. It's too much displacement, so you can either change the scale or keep the scale and just control the scale using a vector math set to scale. So this will change the strength, while this here will change the size of the noise. So you want to have control over the strength and control over the size. Now, one thing I don't like about using the noise to displace the geometry directly, it doesn't really give me the displacement I like. So what I usually like to do is, instead of using the noise directly, I can just import it into a normal, use it to influence the normal. So if I plug a normal directly into the offset, it will push everything outside. Basically, it's the equivalent of having a mesh like this and using Alt S, which will just push faces into the direction of their normals. So if we look at the normals of this mesh under edit mode overlays, turn on normals and just increase the size, you can see the direction of the normals. So if I'm using Alt S, I'm just pushing faces in the direction of the normals like that. So that's what we're doing here, but instead using this here. So I can use a scale node, which is basically a vector math with the operation of scale. Just plug it in here and do the same thing we did here. So we are pushing this out, but we are uniformly pushing things out. We can try something different. Instead of using a uniform value, we can plug in the noise to get something like that. But again, remember, the noise has an offset. So let's subtract that. But because we are using this gray output, which has only one value instead of this color value, which has 3 values, we can get away with using the math node instead of vector math to subtract 0.5. And you can see the difference. So this is before. So if we subtract, you see what we're getting. If you still want control over the strength, you just use multiply instead of scale, and that will give us the same result. We can smoothen these out by using a subdivision surface. I think this is too strong, so I will just... Okay, so this is where we're at, but we don't seem to have the twist going on. So for that, let's go back here when we created this curve tilt. Instead of setting it here, let's just store it into a named value so that we can reuse it here, because here we are setting it, but it's not being applied. Right, it's being applied, but not really giving us the twist we have. I think it's creating good detail here, but that's not where I want it to be. So let me just keep that small detail there and store this value so that I can use it after the mesh. Remember, when you convert a curve to mesh or any data to a different data, you will lose all the data associated with the original data type it was. So for example, this curve comes with a tilt information, radius information, and other data that is connected to curves. So when you convert it to a mesh, that data is destroyed because it's no longer a curve, it's now a mesh. To retain that data, you need to copy it in some way, capture it, and transfer it to another mesh. So to do that, you can either use a capture attribute, which I think used to be the transfer attribute, and then capture the data there. So I would capture it here. And if I want to use it somewhere here, I could just do it here. I could just drag this directly into that, and you can see what we're having. Let me just see what, for demonstration purposes, let me just drag this into the... Okay, so you can see what we're having. It has been transferred correctly, but if we remove this capture and we just transfer it in and we just dragged it directly here, we're trying to plug curve data into a mesh and the mesh doesn't recognize it. So you need to capture it first and then transfer it like that. That's when it works. Otherwise, the mesh will not recognize it. Another way to do that, because you see, if we say we needed this to be in different areas, it would just create a big mess. So another way to transfer data is just to store it in a named variable. So I can store this in a named attribute. Let's call this, just remove this for now. I can store this and call it length, since it represents the length of the curve, like that, and I can use it anywhere I want. And actually I want to use it in its original form before I even multiply it. So yeah, we don't need that here. I can use that data and use a named attribute. I can even preview it now. So it's called length, and if I preview it, you can see it's just values going from 0 to 1, which is basically showing the length of value, a gradient mapped along the length of a curve. we can use this information to rotate each vertex we have along the length of a curve, since we already have that here. So to rotate these vertices, let me just use a set position here, add some space. You can get the position of each vertex connected to the position, which will change nothing because we're just using the same, replacing the old values with the old values, giving us no difference. But we can rotate these values before we set them back into the new position, into their own position. So we can use a vector rotate, and if we rotate this, we're basically rotating the entire mesh, but we can create an offset along the height of the curve so that vertices up here rotate faster or rotate less than values down here. And since we have a gradient that goes from 0 to 1, so we can just multiply the rotation here by 0 and the rotation here by 1, basically just tagging the length directly into this so that these up here have less rotation than the ones down here. We're just rotating by a value of 0, which is not allowed, so we can multiply that using a math node. Multiply, and just now that gives us a more stronger rotation than we had before, which I think is nicer. Now from there, if you want this to be animated, basically all you have to do is animate this value. But the problem with animating this value is going to increase the twist until it untwists. So instead of multiplying this, we can just add to the rotation so that this is continuously rotating. And instead of animating this value, you can use the current frame for animation. So if you use the same time, it gives you the current seconds or the current frame. If I plug this in, I'll just multiply this value by the current frame, but you can see that is too fast. I can slow it down by just using the seconds, and that is too slow, so I can multiply that value with whatever value I want here. So let's do 5, and that's better. Now the next thing at this stage is to add some materials. The first thing I'm going to do is convert this mesh into a volume. So mesh to volume, just like that, and you can see some bit of volume, but if you increase the density, you can really start to see, and the voxel amount can be also increased, or you can just change the size to get and reduce the size here. If we go to the materials, I'm previewing this in cycles, and let me add in a sky texture or an environment texture and switch to material tab. So shader editor, create a new material, give this a principal volume, increase the density, and we need to set this material in geometry nodes as well, otherwise it won't affect it. So let me call this volume and switch back to geometry nodes. Make sure I set material here, geometry nodes volume. Now that's what we have so far. And one other thing you want to do when working with volume, you need to make sure that the mesh is closed and not just open like a tube here. So to do that, we are going to do what we talked about before, just selecting boundary edges here by selecting the edges that have one face. For example, this edge has one face here, and these have two, so we won't be selecting that. So let's go back and do an edge neighbor and use our compare node, and just use greater than, select any edges that have a face count of greater than 1, and delete those edges. So connect this and this. Let's see now. Yeah, so now you can see we have the two loops. You might be tempted to convert this to a curve, mesh to curve, and filling the curve using a fill curve. But the problem with that is that it also collapses the curve. It doesn't make them 3D anymore. So that's why you see I did not do that. So for this, I just instead use an extrude node to extrude the edges like that, and then extrude it again, making sure that I only extrude the last edges. So at the beginning, we have this geometry, and these are the edges we want. So if we extrude them, and now we want to only extrude this top ring, which thankfully this node here gives it to us in this top selection. See, if I connect this and then use it here, you see we have extruded it, but we have this offset that determines how far the extrusion goes. So we have that. And one other thing is that I want to collapse this, so merge this edge into a point, into a circle to fill this in. So let me first show you what I'm doing. I want to scale this in. If you use the scale elements, you can change the size of your extrusion without using the offset. So I can use the scale elements, but instead of face, I want edge. And again, I only want to touch these edges we have extruded, so I'll use that. Now I can scale this in to give me something like that. And if I repeat this extrusion, again using the only selecting the edges, the top edges, we get that, and I can again scale elements, again using only the top edges, the last edges. But this time, instead of scaling it, I can scale it by 0 to match them at the center like that. I can also reduce the offset on these so that they don't get too pushed. I think that's good. Now I can bring in the old mesh, this here, merge it using the merge by distance with this here, with this. But before I use the merge by distance, I need to join this geometry and this geometry. So we have 3 entities or 3 meshes, and I can prove that by using the scale elements, but this time use the face. So you can see I have 3 elements that are not connected. If I turn on the merge by distance, I can merge the vertices that are close together. Let me just re-add that. Merge by distance, but before the face. So now when I scale this, you can see it's scaling as a single entity instead of what we had before where these are separated. So I want that. Enable this, and we have our volume. The only thing I'm saying is that the faces down here are flipped. So let's unflip them. I'm going to go here and just select this mesh. So since we have 2 faces, let me first turn off this face orientation. Since we have 2 meshes and I only want to flip this, I can use the mesh island to give me the index of the different islands. So if I use the delete geometry and just select the index here, I can look at what this island here has an index of 0 and this has an index of 1. So we want to just use the flip faces and use the index to select what faces to flip. So if we look at the face orientation again, they are all facing the right direction. So now we can do the merge thing, and we have a face that is well connected into a single volume, just like that. Now we can go back to work on the materials. Okay, for some reason the volume wasn't rendering, so I just switched to Eevee and back to cycles, and then it started rendering. So that seems to have been a bug. So let's go back to the shader editor and look at what we have. So there are 2 ways to turn this into a volume. You can do it here in geometry nodes by just using this mesh to volume, or you can do it directly in the material editor. So if I turn this mesh to volume off, you can see and go back to the shader editor, because we have this already set up as a volume. Let me first turn off my orientation and some of these extra objects we have. Because I have this principal volume, I'm able to look at this as a volume. The difference is that this tends to create a more harsh, sharp, detailed volume than if I set this directly in the volume shader. So if I just bring this down and go back to the geometry nodes, set this back as a volume, turn this back on. You see, this becomes a bit softer. We'll lose some of the detail. So it's going to depend on what you want. But if you want, you can just remove that and go to the materials directly and just use that as a shader because it retains most of the detail. And I don't like that these are too sharp. So I can come back here to geometry nodes and look at this vector here. I think, where do we get our noise? So this is our noise area. If I disable that, you see we don't get any of that. So I can come here and use our blur node, change the attribute to vector because we want to blur this vector value, and just give this a more smoother look. I can still also add more turbulence to this by looking at what this position does. So it's what gives us these more exaggerated rotations. So what I can do is add some turbulence to that by introducing some noise. So I'll just grab a noise texture, use vector math, to add these two together. So I can grab this and connect this to this. It's shifted. That's because, remember, the noise texture comes with an offset. So let's subtract that offset which is 0.5, and we have something like that. You can control the scale or the strength by just adding a scale value here. Just introduce turbulence, but not too much. Can even add some distortion like that, and we can increase the subdivisions level here to make this even look smooth. Now we have our tornado. You can make it less dense, somewhere like that, and if you want, you can add some noise as well, and connect this directly here. Add a math node to first subtract the offset and then multiply by a larger value, and increase or decrease this to introduce some bit of detail in there, but I prefer just to keep it like that, keep it simple. Now let's work on adding extra detail. So for example, in this original version, this cone is more wider. So to make it wider, we just have to go back to geometry nodes and look at our profile here. Can make that wider, and to even make it even wider, we can add a math node around here, set it to multiply, and now we have a really wide stone. Perfect. Now, if you want it to be more turbulent, just go to the noise, this noise here, and make it more stronger. Can reduce the blur. Now you can see now we get a more turbulent effect. And remember, the height can be controlled by this curve. Just like that. Now let's add this lightning effect, which is quite simple. All you have to do is you can add a few lights, just a point light somewhere inside the volume, so something like that. Yeah, you can make it really powerful. Let's give it a bluish color, and just animate its power. So I can just have it on for just like 2 frames and then turn it off completely. So we can do, it starts off, goes on and goes off, and now I can just repeat these randomly in different areas. Yeah, so something like that. So it goes on, goes off, goes on, goes off, and I can even make it even more detailed by using Control Tab to tab into the curve editor, select the point and select the power that we have just animated, and give it a modifier, a noise modifier. This will introduce some noise to the brightness, so it will just look like lightning. I just have to increase the strength quite a bit, and the scale should be really low so that we get a really strong frequency, a high frequency, and something like that. And it's also going in negative values. Sometimes that causes issue, so you can add a limit, some limits, and the limit I think is the minimum Y, so that this is always, when it goes off, it doesn't go into negative values. So we have something like that. And now what you can do is make sure you don't have any keyframe recording, so that we don't record any position keyframes, and just duplicate this in different areas inside this, and just make sure that the lights are randomly placed in different locations. And now just offset the keyframes, scale them down, scale them up, move them around for each light to make sure that the timing is quite different. And you can even duplicate some of these just to make sure that the timing is different for each. And I'll just do this. So yeah, something like that. And I can also add an empty at the bottom. So Shift E, let me add this spherical empty at the bottom like that, and rotate it in the same direction, animate it rotating in the same direction as our tornado. I'll select the keyframes, hit V so that it's linear. And I also want this to rotate faster, so I'll use Control Tab and look at the curves. I think I'm rotating this I want this rotation to be mostly in the Z, so I'll select the Z rotation, use Shift H to hide all the other keyframes, and I zoom in. So I can move this up so that I increase the rotation, can even increase it more, and that will make sure that this rotates faster. Let me just have it somewhere like that, and I can parent now all my lights onto this, Control P, so that it appears like the lights is randomly rotating. There is lightning in the tornado like that. Okay, let's work on the debris. So I'm just going to grab a few objects. Yeah, we have these pieces and we want to add them as extra pieces in this simulation. We can have them in a collection. I'll just call it C, and come here. I want to look at this mesh. So this here, I think I want it here. Yeah, around, I want to start to instance these when it's at this stage here. Maybe with the rotations, I think. So we can distribute points onto the faces to get something like that, and instance on those points, instance on points, just like that, and grab our collection, separate and reset, make sure this is set to origin, and just connect this as the instances. Make sure you have peak instances. The rock is too big, so I'm just going to select everything and apply the scale. Let's go back to our tornado here. Now we can see we have a lot of chairs, we have a lot of rocks, and that's good. But one thing you will notice is that some of the rocks are disappearing mid-air, some of the instances are disappearing mid-air, and that's a result of this distribution thing. The way it works, it distributes points based on the area of the faces. So when the area changes, and remember, the area changes because we are distorting this, we are displacing this mesh with animation. So the area keeps changing, which will remove some of the points. That's why we're seeing some points popping out and out of existence. So we can go back to somewhere where we don't have a lot of distortion. Yeah, something like this. Yes, somewhere like that. Now we shouldn't see any popping out, but we also lose the animation. We can bring back the animation, but before we do that, let's add some random rotation like that, which is good. And to bring up the rotation, we just have to use a set position and basically just use the same position here. Let's make sure we're previewing this. Yes, the same position we have there, but this goes into the position. Perfect. If we join these three or these two pieces using the join geometry, you see that it's like these are stuck onto the tornado. Let's preview this. Yeah, you can see it's like these are stuck onto the tornado, which doesn't give us a good effect. So what we can do is come here and push them away from the tornado. And the way to do that, we can use another set position, and these points come with a normal direction. If we push that in the offset, you can see it pushes those out a bit away from the surface like that, and we can control that using a math node, vector math. Change this to scale, so we can push these out just like that. The problem we are having is that some of them are being pushed down, some are being pushed up, depending on the direction of the normal. Remember, we are using the normal. So that could cause issues. We might see if we add, say, a ground. Let me add a plane like this and just subdivide it a few times. And let me use my texture folder add-on to look for some ground textures. Let's use this, and I'll add a displacement, a new image. I have some displacement textures, maybe this. It's too tiled, so I'm going to add another empty to scale it down to control the displacement here. So I'm just going to select this, go to the modifiers, change the coordinates to object, and select my empty, to scale this, and I'll shade smooth, maybe even add a subdivision surface or a multi-resolution surface above this displacement, so that I can subdivide this maybe twice and reduce the strength just to have some detail. And for the texturing, I can go back to the material because I think these are too large, the texture is too big. I'll just scale this maybe 4 times, just like that. Go back to geometry nodes. Okay, so this is where we are. Like I said, you see, if we just use this normal and scale it, you see some are going to be pushed in and some out. So we can change this to multiply, and this can also let us do the same thing, but we can limit this in 2 axes, in only 2 axes like that, and we get something like that, which is great. The only thing I need is to add some random rotation, because these don't look very random. So to do that, I have this rotation that is giving us this rotation. I can add, I can use a vector math to add more rotation to it, just like that. So I can, as you can see, we can rotate these just like that. So we can use a time. You can use the same time to add rotation to these. So if I use this, we get some rotation. I can even use a math node, multiply this. Yeah, so we get something like that, but it's not random enough the way I want. So I can just, instead of this, I can add a random value. I can add a random value. Let's do so I can let's multiply a random value like that. So let's do it. Yeah, so we get a nice rotation like that. Now you can increase the density as much as you want, but you see, we're starting to run into a problem where we have way more tables, way more chairs than rocks. We want more rocks than chairs. So you can either create another instance of distributed point, basically this whole setup, and just use rocks so that you have more control over that, or you can do what I did in the original version by just importing individual objects and creating your own collection. So I can just bring this in, make sure this is set as an instance, connect it like that, and now we have rocks. But I also want some chairs, so I can bring this in, but as an instance as well, and then join this so that we have different instances, so that will mix between rocks and chairs. But if I want more chairs, if I want more rocks than chairs, all I have to do is use the duplicate elements. That way I have more rocks in this collection here than I have these chairs. So something like that. And I can also bring in the wooden other objects like that. So if I want more chairs than this wooden thing, I will just duplicate this maybe twice, and here maybe once. Or if I don't want any of these, I can just set this to 0, and that will remove them. So you can have as many as you want. I want the rocks, I don't want them to be the same scale. I want to have some random scale in the rocks, but I want all the chairs to have the same scale. So for that, I can just come in here and use a scale instances. Here, and just scale these randomly using a random value. Connect this directly there, and you can see I have now smaller rocks and larger rocks. So I can increase the seed, or I can increase the density, let's say 100. So we have a lot of rocks, and I can bring in, let's say, what else? This broken chair. It has to be an instance because we are dealing with instances here. So I can just bring this in. Also make sure that I can limit how many I want. So yeah, you can see the chairs there. They're too small. So I'm going to scale it up using the scale instance as well. This one doesn't have to be random. You can just do this, and we want only a few of these. So maybe just scale them up a bit. I think there are too many, so let's do 2. Yeah, we want more rocks. So I have these rocks, but they're not tiny enough. Actually, let's do something like that. Let's do a density of 1000. That's too much. Let's do 500. But we want to have more smaller rocks. So I like this size, but I also want an even smaller size. So I'm just going to duplicate this rock again and plug this in. So this is going to be the large size. Let's do 100, and I can have an even smaller size of the rocks in there. So you can see how we are layering effects onto effects. So then the next thing is adding these rocks on the ground that rise up. Are these bottom rocks that rise up, and then we can add the background speeding air. So to do that, we can just select this mesh, give it a new geometry nodes so that we can work on that. Again, we just use a distribute points on faces. So we have these points. We can turn these into rocks by using instance on points, and just instance on points and just instance our rock. So use this. We want random rotation and random scale. So let's do a random value, just like that. I want even this to be more random, so I'm going to use a random value. But this time it's a vector, so this can be -10 and +10. to get a random value here instead, just like that. Now we want this to be animated going around like this. We're going to use, let's use a simulation zone, because we want to add rotation to these middle ones. So I can just get these and get these. So to have objects rotate in a circular motion, what you could do is use a set position to change their position. And if you use the cross product of the position, this is a vector math operation. So if you add a vector math, you'll find the cross product there. I just dragged this and typed in cross product, and that came out like that. So if I use this, I think it should be here, and give it a cross product in the Z value like that, it will just give this a rotation like that. But things are getting really slow because we have a lot of particles. So I'm just going to come here and first reduce this to limit this to 100. So things are much faster. Okay, so this is what we have. Another thing I want to do, I want to limit the objects that are affected by the rotation of this. So I want only the stones closer to the vortex or the tornado to be rotating. So to do that, as we can just get the position of each node, of each instance, find the distance from the center by just using vector math and changing this to distance, and that will give us a gradient. If I'm just looking at the points, you can easily see that gradients, especially if I map it to a range, let's say a distance of 14 mapped to 0 to 1, you can easily see the gradient like that. I can even add a float curve to emphasize that range. So if but I think this time I want this to be flipped. Yeah, so something like that. I can scale this cross product by this. So I can just use a vector math, change this to scale, and use this as the scale. So now you want this to be in the offset, not the position. That way we have something like that. But that seems to be rotating the entire thing. What we can do is instead connect this directly into this. We get that. We want this to be flipped around. So I'll just flip this range from 1 to 0 instead of 1 to 0, instead of 0 to 1. And I can even scale down this cross product to maybe 0.2. Okay, so that is not going too fast. I can use a ramp, yeah, to just slow down the particles at the end here. So you see what we have. So only these are moving. So we have something like that. I can even just bring this closer. Maybe even change this to B-spline so that there is still some slight movement at the edge. I can add another node here, but make it darker. Yeah, so that there is slight movements, but the ones at the edge don't really move at all. Okay, I also want this movement to also go up as well, so I can add another set position, and this time use a combine XY and connect this value into the Z. So something like that. And I can use a float curve to just make it more, yeah, tighter like that. Now it seems our particles are going the wrong direction. So I can just rotate this by negative, change this to -1 so that they go the other way. I think I'm just going to reuse this here. Yeah, we have that. Now, if you look at this, this looks way more violent than what we have. But when you look at it in the viewport, it doesn't look that more as violent as it is. That's because we have some motion blur and maybe these extra particles, these wind particles. So let's add that. So to do that, I'm just going to use a cube, scale it to the size of the wind of the, scale it like that, and give it a new material. This is going to be a volume material, and to see it in the viewport, I'm just going to change its viewport display into wireframe. Okay, so I want this to render as a volume. We want to use some noise, so I'll use noise. Now connect this into the density and use a ramp, a color ramp, and you can see our noise there. I can even just add it like that. Then the other thing, I can use Ctrl T to bring in these coordinates, and I want this to be set to object coordinates because I want to rotate these in the Z direction so that they rotate around the object. I want to make this a bit darker, so, and very sharp. Another thing I did is scale these down a bit, maybe, so you can see that, and just animate this Z value using frame divide by 10 if it's moving too fast. So then we have that. I can bring down the lighting a bit and add some extra lights to this, so maybe an area light, and that will also help show the volumes, the wind effect. Now this can be a bit like 50 or 100. Remember, you still have a lot of control over different parameters. Like I can go back to these geometry nodes and just change the scale. Maybe even make it taller. But if you don't want to use an extra curve, because I don't even see why we used an extra curve, you can use a curve line directly from geometry nodes. A curve. If you change its height, you're basically getting the same thing as in editing that. So instead of using this, I can just use this. Now let's look at this now. Okay, this seems to be flipped around, so you can reverse the curve and you have something like that. So now you can control the height directly like that. I don't even know why I didn't do that way in the first place. So the next thing, if you want to make this look even more violent, you can animate the camera moving forward and give it a shaky animation. So I can just animate this moving forward, and then go tab into edit mode and curve mode, and you can animate the Z direction, give it some noise. Let me preview this in Eevee for a second. Give this some noise, and you can see if you give it that shaky feel, I think this is too much stronger than I want, so maybe something like that. You can really make it look as violent as we have here. You just have to render with motion graphic with motion blur, and that should give you the same effect. Thank you for watching. I'll see you in the next video. If you have any comments, you can leave them below and tell me what you think about this way of teaching, and I'll see you in the next video. Thank you.